Welcome to AU Manufacturing Conversations. Good to have you here. So let's get to know one another. The first question we always ask our guests is, how did you get here and what do you make?
So I'm Phil Fox, I'm CTO for Eco-Detection. My background actually is in physics, optical physics, but a long career in instrumentation and processing systems and control systems for those sorts of things. Come out of sort of high volume manufacturing in the printing sense and have come across to do systems development, starting out with Grey Innovation a few years ago, and have now been heavily involved in one of Grey Innovation's spin-out companies, Eco-Detection, which is where I'm now CTO, and involved in taking the technology that came to us from university and taking it out into the marketplace.
And you over there?
Yes, I'm Lachlan McLaren. I started off as an electronics engineer at Grey Innovation. I'm currently project manager for Eco-Detection through Grey Innovation. I moved from electronics engineering into the project management side of things during the notus ventilator project, where I was doing some assistant project management for managing the consortium of suppliers to build 2,000 invasive ventilators. And then from there I switched to Eco-Detection, but still in a project management role instead of returning as an electronics engineer.
All right, well, it's not the focus of our conversation, but in any case, it would have been a pretty decent introduction to project management roles, a baptism by fire, I'm guessing.
It was, and also a good introduction to manufacturing, particularly higher volume manufacturing and leveraging such a large supply chain exclusively in Australia. I kind of got all of these things combined into my first management experience. So yes, absolutely. And high intensity, 7 days a week, 8 days a week with Phil. But very exciting and kind of inspired me to get more into the management side of things and around manufacturing.
So I think key to the reader understanding anything, if we go any further, would be a bit of a description of electrophoresis, which is something which Eco-Detections and some of the other related companies' technologies are based on. What is it?
Yeah, so electrophoresis, which is, as you said, the core part of the technology and the instrumentation that we've developed. It's an analytical method. It's been around for a few years, and it's a process by which you can take a sample and you can separate out constituent parts. It gets used for drug analysis in various forms. It gets used for DNA analysis. What really we've done is we've taken that process and developed it into a technique that's targeted much more for monitoring water quality, and particularly nutrients in water and inorganic ions.
I'd like to go back to the, origin story stuff. Tell me about what the work was that was being done around that technique at University of Tasmania and which has led to all these related businesses.
So the University of Tasmania had been doing work with the support of the Australian government around analysing fertiliser-based explosives. So initially around post-blast analysis, so sort of looking at the components of residues, but also that led to work about how you look at the components in those sort of improvised explosives. So different to military grade, the electrophoresis process was conducive to being able to separate out the individual components that might be used in a fertiliser-based bomb. And so that work developed and got to a point where it was coming to a commercialisation process, and that's where University of Tasmania got involved with Grey Innovation, who sort of specialise in taking technology that's been developed to that prototype stage and taking it out into a commercial product. So Grey Innovation got on board and they started developing, and they turned that into the first system, which was for the explosives trace detection, and that's in the spin-out company GreyScan. And that's really geared towards rapid screening at airports for looking for those fertiliser-based IED type devices. And that had a different set of guidelines that it was trying to work towards, where it's really important for it to run quickly. But of course, the same sorts of analysis, if you're looking for things like nitrates and ammonia-based explosives, those things are also really useful in environmental monitoring. And so Grey Innovation with the university sort of saw this opportunity to say, okay, well, let's have a separate company where we focus on that sort of market. And that's kind of where Eco-Detection came from. So the core technology itself is very similar, but we have different drivers. In the environmental sense, where Eco-Detection is working, our customers don't necessarily need the response in 40 seconds. But what's much more important is around accuracy, reliability, how long it lasts in the field, service intervals and management, those sorts of things. And so now we sort of have these two separate companies operating in different markets, but still based around the very base core technology.
Having a research breakthrough and getting to the point where it's nearly ready to be a spin out or whatever, and having it viable product. There's a long distance between those two things. Tell me about some of the things you had to do to industrialise and, as you said, get the result for the explosives detection down to under a minute from what I think was around about an hour or so at the beginning.
I suppose there's lots of stages in the process, and I guess that for the two different companies, understanding the market requirements is always the first part of it, right? This is a sort of technology push, right? So it came out of the university, here's a technology, but then we need to make sure that aligns properly with what the market needs. And so, as we sort of said, in the case of explosives and screening, time's really important. And you certainly want to have good sensitivity, but once you know there's some of those explosives there, you're probably not as interested in actually how much is there. It's enough, right? But in the case of environmental, we had to be more concerned about how accurate we were. The process to sort of go through that and look at what do we need to do to the system to make it stable, to make it more reliable, that really involves talking with, what's the environment it goes into, what are the sort of markets, who are the people who are using it, and what does that need to do. And initially, obviously, it needs to be able to communicate with the water, it needs to be out in the environment, which means we now need environmental protection. The explosives trace detection is designed to operate in an internal environment, inside an airport. So there was a lot of work around the fluidics interface, the environmental protection for the device, how we fully automate the sequence so that it's completely hands-off, and how we make sure that then also works with any other systems that the customers are using.
All right. And so, again, a similar sort of question. How long did it take for beginning this relationship with the separation scientists in Tasmania, from that to having, your first product out there for GreyScan?
For GreyScan, I don't think it was as long. I met Jefferson, who's the Grey Innovation Director, and obviously Director of Eco Detection at GreyScan as well. And I met him at the start of that process, which I believe was 2013, 2014. And then I wasn't actually working here until 2019, and by then it was almost a fully... GreyScan had their own facilities. It was a pretty much fully commercialised product. So I guess 5 years from start to finish. And I've seen some of the base setups that the University of Tasmania had, which was really around ensuring that the capillary was fit for purpose and that they were getting fluid through and that they were getting separation. And the concept of the phase-locked loop, which is the actual conductivity detection method, that was kind of tried and true. What Grey Innovation's involvement was condensing that, making it more efficient, making it cost-effective, all on board, integrating some things like optical transceivers to move analog data across rapidly and those sorts of things. So the capillary part was quite set, the electrophoresis, the CZE, that was quite set. It was all the infrastructure around that took, I think, most of the development time. And then the transition from that to developing eco detection, I think, was even more rapid. The turnaround from using the GreyScan core modules into Eco's own bespoke kit
It's probably, 18 months to 2 years.
Yeah.
And did you have an initial inquiry that led to you developing what you have with eco detection, or did you just sort of organically go, oh, this could be used for this, let's see if that's the case?
Yeah, I think it had already been flagged in when that technology had already was coming out at the university.
Yep.
There was already the notion that, okay, this is directly applicable in both of these applications. So I think that was already there. So then there was a bit of, testing the market, looking at how receptive the market would be to that and trying to gauge that. And really, but that's more around the kind of the business process, right? Before we start the spin out, understanding what's technically possible, is there actually a market and a demand for it? I think there was more research on our side in terms of going out to market to understand what the potential would be in that case.
Mm-hmm. So let's hear about your team here. How many, well, I guess, what are the sorts of staff you have working across the Grey Innovation companies, and is there much crossover between the different divisions?
Yeah, there certainly is. I mean, it is all within the group, and kind of we've got employees who are sort of spread across sort of eco detection, Grey itself, and GreyScan. And there's certainly a lot of collaboration across those groups, and depending on who's got the skills that we need, we have occasionally, and actually we're doing it at the moment, we've got staff seconded from some of the groups to others where we need to bring in those resources. Eco itself tends to focus more on obviously the commercial side, the sort of product development, making sure the product goals align with the market, and the deployment side, how we get those things out into the field. Grey Innovation has the background in product development and engineering design, so they do whilst Eco sets requirements, Grey then helps us with the design process and manage that under their frameworks. And then, of course, we've also got engineers at GreyScan who, particularly on the software side as well, sort of help us out, as well as they're a bit further ahead in manufacturing, so we get some feedback from them on different issues and challenges they've faced, and we sort of feed that back across all the companies.
You've had 2 products released through Eco Detection, is that correct?
Yep, there's sort of 2 iterations of the product that are now out in the market.
So tell me about what each of those does.
Yep, so the first was our IonQ product, which is our sort of baseline product for measuring anions in the water. And particularly this is geared towards nitrate and phosphate monitoring in environmental systems, where we're looking at sort of the use of fertilisers, synthetic fertilisers, and how they potentially run off into environmental systems and how that leads to excess nutrients in rivers and algal blooms that can go from that. Also applicable in the case of a lot of discharge monitoring, so from industrial wastewater treatment, sewage treatment, and those sorts of things. That version is the single channel version, so we can set it up to run to look for those anions like nitrates, nitrites, and phosphates, or we can set it up to run some other ions like ammonium and that sort of thing. But the second version of the product is our IonQ Plus, which brings those capabilities together into a single device. So having a dual channel system where we can have different configurations in the channels that allow us to choose from a broader suite of things to measure. So into that one device I can measure the different forms of nitrogen, nitrite, nitrate and ammonium, and I can measure phosphate and potassium and a sort of a range of different things that go together. And that's really geared towards having in a single device, a more comprehensive suite of nutrients, so you get a fuller picture of the chemistry in the water, but especially suited to the wastewater environment, where having that information on both the nitrate, the phosphate and the ammonium is really important for how you're managing the process in that wastewater treatment plant.
Right, and are you able to say anything about your customers further than what you already have?
Yeah, I suppose we've got a broad spread of customers. Initially, a lot of our customers are in sort of the monitoring sort of space, environmental management, wanting to understand what's happening across the river system, what are the different inputs into that river and how they have downstream effects. And this is where you're starting to look at getting real-time information on transient effects that can have potential downstream effects on your water source. Things that you might miss in the sampling scenario where you're going out once a month. So that information, which is good for very long-term trends, it doesn't tell you anything about the dynamics in your system or propensity for short-term events and what those short-term events might then trigger in terms of, say, algal blooms or bacterial growth and that sort of thing. So certainly in that space, a lot of our initial work was around that environmental monitoring, but that's also led into compliance monitoring, so where you've got people with discharge licenses and wanting to understand what's the impact of when and how much they discharge on the river systems that they go back into. And then from that, we're also now moving, as we sort of talked about earlier, into the sort of wastewater, where having that ability to do the real-time monitoring actually not only means you've got a better idea of what's going out, but also what changes you can make upstream in the process to sort of manage for that and improve the outputs.
The ability to monitor ammonium and that use of that by wastewater treatment customers was part of the reason you were within our top 10 most innovative manufacturers a couple months ago. Congratulations again on that. I bring it up because I like doing that, but most importantly because I would like to know a little bit more about how that innovative solution has helped save energy for wastewater treatment users.
So I guess an extension of what we were talking about earlier about how having better data about what's sort of coming out, it gives you some ability to change how you control the process. What sort of came out of that also is an understanding that if you can monitor also the inputs to your system, and I guess like any system, right, the more data you have about the inputs and the outputs, the better your ability to control it and understand what are your levers, what things can you change in the process. And in the case of wastewater treatment, the ammonium links very heavily to how much energy it takes to treat that water in terms of being able to remove the ammonium and get it out of your water takes a lot of energy, and typically it's done through an oxidation process where you have to add air into the system. And that's actually a very energy intensive thing to do. It's typically around 50% of the energy costs in a wastewater treatment plant, and actually is significant. I believe in the US, something like 2% of all energy is consumed in wastewater treatment. So we're talking about a really big energy consuming process. So anything that you can do that helps you optimize that process has really good flow-on benefits. And typically those processes are managed through monitoring things like oxygen in the water, or sometimes they're managed just on time-based cycles. So being able to do real-time ammonia measurement, which is kind of one of the key inputs for that process, means that you can optimize the system better. And there's plenty of papers around this, right? We didn't invent that part of the process, but what we identified is a connection where we said there's a need in the market for better ammonium control, because if I can do that, or better ammonium measurement, then I can implement better control. But typically there's an issue with ammonium measurement at that part of the process, and the sensors that are normally used are not very robust. So we identified that actually our solution was much more conducive to being used in that part of the treatment plant. And that was kind of the missing step for why these systems to do ammonia control had not been implemented as widely. So really we're about sort of unlocking that capability and helping sort of drive that process for broader adoption.
Another thing I wanted to ask about was a recent Linkage grant with University of Tasmania, continuing your long-standing collaboration with those folks. What is this project around, and how does it fit into the future of eco-detection?
Electrophoresis, as we sort of spoke about earlier, it's a generalised sort of method, and it's quite extensible to different things that you want to measure. And so in our case, working with the university, we've sort of identified a roadmap of different things that we want to be able to measure in future. And this Linkage grant is really about moving along that and developing the different applications and the different chemistries and detections that we'll need to do those things. And the priorities in that sense for us are things around like heavy metals detection. So at the moment we can measure things like magnesium, calcium, iron, a bit of zinc, but there's applications obviously in the mining industry where you do want to look at much sort of heavier metals and how those things potentially either leach into the environment or how your treatment processes are going to remove those. And so this Linkage grant is about moving along that path and getting to the point where we can have a version of our system which can do that heavy metals detection. That's kind of a stream. There's a second stream in there where we're starting to move into the marine application. So we have one system actually which is doing some early trial work in a marine environment so that we can be looking at some of those nutrients in seawater, and the Linkage grant will take us further along that path so that it expands both our suite of things that we can measure and the range of environments we can measure them in.
And that was mentioned earlier, the marine environment application before the tape was rolling. I'm not sure if you'd like to expand on that, but it was pretty interesting in terms of Great Barrier Reef credits. If you can't talk about it, fine, but if you can, I'm all ears.
It's certainly fine. There's a couple of things there. So one is we're doing a project where we're looking at nutrient runoff for rivers that go out to the barrier reef. So we're not particularly measuring in the marine environment there, but we're looking at the upstream. Right? So we're looking at, as the rivers sort of flow through pastoral areas, how much nitrogen are they picking up, how much nitrate, and what can we potentially do in terms of mitigating actions on those rivers to sort of stop that before it gets out. I think there's plenty of research showing that those nutrients going out to the Great Barrier Reef has a significant impact on those. And there are now nutrient trading programs where as people put in mitigating actions, they can then claim credits for the nutrients that they've reduced or they've prevented from flowing out to the reef. But really key to that is also being able to demonstrate, well, how do I measure, right? How do I measure what my mitigating actions have done? And it's not as feasible to do that once a month because you're just not going to get data and you're going to miss all the rainfall events where all of this stuff happens. And so being able to do that real time and provide a solution from what's called measurement, reporting and validation is really critical to that sort of protecting the marine environment. The second application is that we're actually measuring inorganic carbon in the marine environment directly. So on systems measuring seawater, looking at inorganic carbon, and that's then linked to potentially carbon uptake in water through things like seaweed forests or seagrass restoration projects. So there's a sort of a whole range of things where we could be looking at directly what's happening with the inorganic carbon in the water.
A few times I've spoken to Jefferson Harcourt, the founder of GreyScan Group, And he's been particularly passionate about the role of government in encouraging innovation, particularly through procurement. I was wondering if you had any sharing of his passion, and if you'd like to talk about it perhaps in terms of the NRF, if you want to be a bit topical, or if you have any other thoughts on how government might encourage the development of new technologies that have a global relevance.
Jefferson and I are quite aligned on this, and I'll separate the two things out because I think the NRF is kind of different.
Yep.
And really it's about the first part is about what's the role of government in helping to establish and drive the market. So because they're not necessarily always active in the market buying solutions, there's always this degree of uncertainty. And often even when you then end up trying to export, questions you'll get is, well, why is this not purchased by your own government? And so, I think there's certainly a role where government can be an active participant in the market and actually helping to drive what are the requirements for the product, what is it that they would like to see in it for them to be a purchaser of that product, and then to some extent a commitment to say, all right, if you achieve these goals, then yeah, we'll buy it. I suppose it's a little bit more than sort of letting the free market run, but it's about helping to establish what the need is and helping to establish a market and really help companies get off the ground in that sense. The NRF, I guess, is a bit different because it's really an investment fund, right?
Yeah.
My personal opinion is I think the framework is still being developed, so I guess we can't speak too much to it.
Yeah, there's no mandate yet.
There's no mandate yet, and I think what will be critical to it is what sort of risk appetite they're prepared to establish in that fund. At the high level, its mandate is to operate as a commercially focused investment fund generating positive rate of return, which actually just sounds like any investment fund or any capital market. So what is it that the NRF is doing to help drive that innovation? And I think that will really come down to how much risk they're prepared to take on companies that are perhaps not as mature or a bit earlier in the sales cycle, or who have a sales cycle that is quite slow if they're sort of working in that sort of government areas, where it's difficult for those companies to access capital markets because the sort of immediate rate of return is not there. So I think in that sense, it probably just comes down to what that framework is that they get. And ultimately, it depends what their measure of success is. Is it about the positive returns, which is great, good for the taxpayer? But if they're trying to drive innovation, they're going to have some companies that will fail, right? That won't have the right risk appetite if all of their companies they invest in are a success. They're probably not doing the right job.
Yeah. What's the market failure they're addressing?
Exactly. Yeah, exactly.
Closing stock question for this podcast is, what's an issue within manufacturing that isn't currently getting the attention it deserves? Phil and or Lachlan, if you'd like to share your point of view, would welcome it.
I can definitely start us off. I think one of the great things we saw was that during the ventilator project that the Australian manufacturing industry is obviously quite alive, and there are a lot of key players and a lot of people that are putting a huge amount of themselves out there to provide production and manufacturing services. The AMGC has done really well at capitalising on that and encouraging that linkage between particularly early stage manufacture and lower volume manufacture, which is great because historically you've obviously had to go overseas to get small volume production cheaply, whereas now we've developed really strong engineering links between manufacturers and design houses, and that's critical. And I know other companies similar to Grey Innovation have done that as well, and that's really fantastic. The government support in connecting these resources and encouraging particularly early stage and early phase development production locally, I think is important, because what often happens is because you can get prototype parts quickly overseas and cheaply overseas, people tend to assume that that's the way forward, or that you're making a minor bridge to high volume manufacture where again you're going low cost overseas market. I think in encouraging the full cycle from I have a very early startup, I need prototypes and I need things like design for manufacture or design for test, stuff like that's not spoken about that much anymore in Australia, and it's a service that manufacturers are happy to provide if asked for, but it's not being promoted. So a connection from early phase all the way through to volume production and an encouragement of design houses doing that and manufacturing houses doing that is really important. We've kept all our relationships from the ventilator project as key manufacturers for eco-detection and other Grey Innovation group companies, and that's been fantastic for us because they've provided us with manufacturing insight that we don't have in-house, and it's actually made the product cheaper to build overall, quicker to build, quicker to install, more robust. They do testing on parts that you wouldn't get that level of testing, end-of-line testing overseas. We have incredibly tight tolerances on things like the capillary and our fluidics pathways, and even any of the analog electronics have to have very little noise. They have to be incredibly tightly done. So the suppliers that we work with provide us with all of that, so it de-risks a lot of the manufacturing process for us. That's another opportunity to encourage that relationship between design houses and suppliers to make substantial long-term linkages as opposed to quick one-off spins.
Sometimes the idea of capability directories and things like that are suggested as a way you could better link companies so they could have a connected ecosystem and know who's out there. Do you have any suggestions as to how we might better be able to do that, or what might be some ambitious project that could bring that about?
Well, I suppose we brought it about ourselves with the ventilator project,
Yep.
and that was driven by necessity and urgency and pressing need, of course. How you establish that in the sort of medium to longer term, obviously a lot of it comes from relationships, right? Knowing who's in the industry, knowing what their capabilities are. I don't know if I necessarily have a good suggestion of how
It's a hard one, of course.
whether a capability directory would help. I think that's where brokers can play a role. So as Locke mentioned, like the AMGC does a good job and helps to bring something together, and whether there's other forums or other groups like that can help sort of broker those sorts of relationships. But part of it also just awareness, right? Even if you're a startup company, knowing that those sort of groups are around and that you can go to them and look for advice. You don't have to do it all yourself. There is a lot to be gained by having that sort of supplier interaction and leveraging their skills and their experience as well.
Certainly. There are some very capable suppliers out there, and one of the joys of talking to startups is that they're routinely surprised by what they can get made nearby at whatever engineering firm or design firm or whatever, but it's the surprise bit that, fun to stumble across, we could do some job of learning from and perhaps remedy. Anyway, there's my 5 cents for what it's worth. Not very much, I assume. Phil and Lachlan, it's been lovely to speak to you both. Thank you for making the time and for having me here at your facilities.
Thank you.
Thanks very much.
My pleasure.